In this problem, we're going to study potentials. Given the potential of the form x squared minus x cubed, find the associated force and the equilibrium points. State if these points are stable or unstable. Alright, so the first thing is that let's go find the associated force. So recall that given the potential, that the force associated with is F is equal to minus d by dx of u, where u is the potential. Alright, so just plug in the numbers. Minus d by dx, x squared minus x cubed is minus d by dx, x squared plus d by dx, x cubed, and that's going to be minus 2x plus 3x squared, right? And so that is the force. Very simple. All right, so the equilibrium points is actually somewhat interesting. A point is in equilibrium, as you probably realize. A point is equilibrium when it's moving with no velocity and feels no force at that particular point. All right, so let's consider that rule basically. If there's no force, then it's in equilibrium. So F is equal to 0. That is going to be equal to minus 2x plus 3x squared. Let's factor this thing. There's one x out of this thing. It's going to be x minus 2 plus 3x, right? And this entire thing is equal to 0. So there's only a few points that this could be. One is that x is equal to 0, right? And so basically we have x equals 0. And the second point is basically if this inner term is going to be equal to 0, which is true if x is equal to is equal to 2/3, right? So x is equal to 2/3, right? So these are the two equilibrium points that we have to think about. Okay, so now let's basically see if they're going to be stable or unstable. Now recall, a point is unstable. So let's take a step back. Let's just draw what this thing might look like. Okay, so let's draw basically u on the y-axis. All right, so you should always do this first, but we're going to do this now basically because it comes up. X on the x-axis, all right? And so, okay, so I'm going to draw this term first because that's u squared, draw lightly. X squared looks something like that. Okay, so it's minus x cubed. So that's going to be steep, coming in, and just small, like it's going to be flat there, exactly. And it's going to go very steeply at the end like that. That's x cubed, x squared. And if you draw the two together, it looks something like this, right? Rises up and then goes back down again, right? Okay, and this term here is going to be x squared minus x cubed, all right? And so the two equilibrium points, x equals 0, that is one of them right there. X equals 2/3, that is the other one right there, right? So the geometric interpretation of this is to basically look at if it's concave, if I move slightly away from it, I will have slightly higher potential energy, and basically I'll just be forced to move back. Whereas if I'm staying at this point, I'm staying basically at the top of the hill. If I move slightly away from this point position, then I can basically run down the hill, right? Either direction, right? So this would be an unstable point, this would be a stable point, right? Okay. Now, you can do this by showing this graphically, but you can also show this by doing it mathematically. Namely, that you have to show here, this is stable because u double prime, all right? Or the right way to say d squared u dx squared is greater than 0. And here, this is going to be d squared u dx squared is less than 0. So this is stable and unstable. Right? And you could check this for any single point. So by calculating d squared u dx squared seems greater than equal or less than 0, you can check whether or not these points are stable or unstable. Okay, so let's just go and get to it. Let's basically consider this one first. Okay, x equals 0. So let's calculate d squared dx squared u. Well, this is just, well, we know f is minus d by dx of u. So it's going to be minus d by dx of f, right? Which I can plug in now. Minus d by dx of 2x minus 2x plus 3x squared. So this is going to be equal to 2 minus 6x. All right, that's very nice. So let's go x equals 0. That's the point. So then basically d squared u dx squared is equal to 2 minus 6x is equal to 2. So this is greater than 0. So this is stable. Okay, check. All right. Now let's do the second one. Okay, x equals 2/3 d squared u dx squared. This is equal to 2 minus 6x again. This is going to be equal to 2 minus 2/3 is 6. 2 times 2/3. This is 2. This is basically minus 2. So it can be a minus 4 plus 2 is going to be 2. So this is less than 0. So this is unstable. All right. Okay. Hope that would clarify things up. All right.